Hi, this is R120 Palmer, and in this presentation we will be going through your experiment 3, which is the experimental determination of a chemical formula. From this experiment, you'll learn how to do measurements, to take measurements in the lab. When you read the pre-lab packet, you'll be able to understand and practice your calculations with significant figures. You'll also be able to carry out a reaction and from your measurements be able to determine the empirical formula of your product. You will have a pre-lab quiz on your experiment, so make sure you read your lab packet, you watch the demonstration, take notes on it so that you understand the theory of what we're doing and the procedure. Make sure you know all the materials that you're going to need, both chemicals and equipment wise. When you come to class, or if you're doing this just online from our demonstration, make sure you print out the procedure and you print out your data table so that you can complete all of the measurements in your class. Have them signed off so that when you go home, you can actually finish the calculations, your conclusion, and your application of principles. When you're done with the lab, make sure you put them together into a single ordered file, either PDF or document file, and include your signed off procedure sheet, signed off data table. So these will be signed off by your instructor the day that you finish the experiment on your way out, to make sure that you have all the information you need. Do all your calculations and show your work, the conclusion, application of principles, and all of that will be in a single file that you're going to upload on or before the due date in Canvas. The equipment that you're going to need, definitely all your personal protection. That includes your safety goggles and a face mask. For your chemicals, you're going to need manganese, 6 molar hydrochloric acid, and deionized water. For your equipment, you're going to need an analytical balance, an evaporating dish, a watch glass, disposable pipette, a 100 milliliter beaker, boiling chip, asbestos metal grills, and you probably should get 2, Bunsen burner, a match or striker, 10 milliliter graduated cylinder, and a desiccator. Okay, so let's go through the equipment and chemicals needed. So the chemicals you need are manganese, deionized water, and this is your 6 molar hydrochloric acid. For your equipment, you'll want a boiling chip with a 100 milliliter beaker. You want your evaporating dish with a watch glass. Okay, you'll need a weigh boat to weigh out your manganese. You'll need a spatula as well to weigh out your manganese. To measure your 6 molar hydrochloric acid, you're going to need your 10 milliliter graduated cylinder. Here is your disposable pipettes, of which you'll need 1. You'll need a ring stand with a 2-inch metal ring clamped onto it. You'll have your Bunsen burner as well. Here's your matches to light your Bunsen burner. This is your personal protection, your face mask, and your goggles. Okay. So here, this file is on Canvas. This is your procedure. So I'll assign you your balance number, and then basically your crucible or evaporating dish is what you're going to be using to put in your manganese and to carry out your reaction. And we'll go through each of these steps. Okay. You'll also print out and bring to class. This is also available on Canvas. Your data table. So some of these require calculations, but you want to fill out all the data that you can in order to complete this lab. And when you finish getting all your data, then you'll have your sign off by your instructor before you complete all your calculations when you go home. Here is just some of your calculations and results. You want to do your conversions, get your empirical formula, and basically look at your theoretical and look at your percent error. How do we weigh the manganese? So you're going to have an analytical balance. And we already discussed where those are in your room. You're going to zero it. Okay, so turn it on and make sure it's zeroed. You'll have a dry, empty, clean evaporating dish, and you're going to put it in your balance and weigh it. You're going to add between 0.2 and 0.3 grams of manganese. You're going to get that weight, and the difference is going to be how much manganese is in the evaporating dish. So here, basically after I zeroed it, you weigh your clean evaporating dish. And here, after you add in your manganese, you can see here what the mass is. And that difference between these two will give you the weight of your manganese. When you measure your 6 molar hydrochloric acid solution, you have your graduated cylinder, and this doesn't have to be precise, even though a 10 milliliter graduated cylinder can measure volumes up to 1/100th of a milliliter. You'll want between 6 and 8 milliliters of 6 molar hydrochloric acid. When you add your hydrochloric acid solution to the manganese, let me see if I can show you how that works. You have basically your watch glass, and so it's going to go concave side down over your solution of manganese, okay, and then you're going to add in your hydrochloric acid. All right. So to add the hydrochloric acid to the manganese, first you're going to put your small watch glass over the crucible, and then you're going to just add dropwise your hydrochloric acid through the spout. Okay, you can see that there's a vigorous reaction. Okay. The reason you want the watch glass is you can already see on top of the watch glass the steam and some of your product has splattered onto the top of the watch glass. Okay. So just continue to add dropwise until you've added all 8 milliliters of your 6 molar hydrochloric acid. And how do you know when the reaction is done? So what you're going to do is you're going to look for the absence of bubbling, because the bubbling, you are forming hydrogen gas, and that's why you're seeing the bubbling occur. So you're going to look for the absence of bubbling, and you're going to make sure that all of your solid manganese has dissolved. Now, after you've completed your reaction, you're going to have some material on the bottom of your watch glass. So you're going to use a few drops of DI water, no more than a mil, so 1 to 2 milliliters of water, but you need to just like dropwise add it to the bottom of your watch glass so it drips into your crucible. Okay, so to clean the watch glass, we use about 1 mil, no more than 2 mils of DI water, and 1 mil is about 20 drops. So we'll just count the number of drops, and all you're going to do, put a few drops of DI water to wash off whatever was sprayed on your watch glass and let it go right into your solution. Okay. Now, will you be able to get rid of all of the DI water here? No, but the goal is to try to get as much of your product back in solution. Now, we're ready to do the next step. When you evaporate the water, you will not have the watch glass on it. You're going to just go like that. And let me go ahead and show you how to determine the height. Because once you finish evaporating the water, you're going to put your crucible directly on here, and you don't want it at the inside blue flame of your Bunsen burner. You want to do more of a gentle heating. So we'll try to keep this on the higher side. So let's go ahead and do the setup for your beaker for boiling. So remember, we have a 2-inch ring here, and what we do is that We have it high enough. Get your Bunsen burner set up, but we won't do anything there. And remember, this grill is going to go on here. Then your 100 milliliter beaker, you'll need 1 to 2 boiling chips, no more than 2. You just need to make sure it doesn't superheat. You're going to fill it up to about 75 milliliters, 80 milliliters of DI water. Put that up here on the grill. Then this goes on top of your beaker, somewhat like a double boiler. Now let's go ahead and take a look at the setup.
Wait. Yeah.
When you dehydrate your solution, you're going to set your Bunsen burner. You'll carefully balance. Put it your 100 ml of water, DI water here, and let me explain. When you put the spout right there, you're going to balance this right here, but make sure there's no watch glass. And when we adjust it and put our Bunsen burner, you're not going to have it at the hottest part of the flame of your Bunsen burner. What we're going to do is put it at a cooler part of the flame. Okay, so now that you know how to set up your double boiler to evaporate the water, let's talk a little bit about the Bunsen burner. So the Bunsen burner has several parts. This is the tube that goes to the gas on your lab bench. This is a gas inlet. On the very bottom, it's called a needle valve, and I know you've seen the video for the safety talking about how to use a Bunsen burner. Make sure this is open about 1 turn, maybe 1.5 turns. Okay, you don't need to go farther than that. Here, you can see it's covered with the metal, but that is actually where the air intake is. Okay, usually what I do is I have it off in terms of the air so that we get a luminous flame, and then I adjust just to make sure we're not getting a hot flame to work with. This is the mixing tube. This is where the gas and the air mix, and this is where your flame comes out. So let's talk about lighting the Bunsen burner. Okay, so when we start lighting a Bunsen burner, we're going to turn on the gas. Okay. And you can hear it going. Okay. That is a luminous flame. Once we get the luminous flame, we're going to adjust the oxygen. Okay. And the amount of gas. So now, in this Bunsen burner, this is the hottest part of your flame. Okay, so now that we know where the hottest part of our flame is, and we're using the tongs actually to show us where it is, okay, so then we can figure out how high our ring should be to not be here, but be just above that. So let's talk about the placement. So when you have your air vent completely closed, you have a cool, luminous flame. It's like a candle. And what you do is you carefully open up the air vent so you get a good mixture of gas and air in here. And as you increase the content, the oxygen content from the air, you're going to get to the point where you have a really nice hot flame. So the inside light blue at the very tip of that flame, that's the hottest part of your Bunsen burner flame. And that will be sufficient actually to melt copper and burn it actually. So when you do this experiment, this is much too hot for your compound. If you do have your compound in here, it's going to decompose with the oxygen in the air. So what we're going to do is we're going to try to get it, instead of the hottest part of the flame, it's cooler here, so we're going to get it basically closer to the top part of the darker blue flame. So what we're going to do is say, this is my flame, it's around here. So what we'll do is that instead of adjusting when you're near the flame, you're going to adjust the slower down until you're right where you want to be. Okay, so that looks good. Maybe a little lower. Okay, but under these circumstances, what you want to do is you don't bring your flame to your stand. This is all metal and it heats and you can burn very easily. What you're going to do is you're going to set everything here, your stand, and then bring your flame to the stand. So you have basically your 75 milliliters of DI water with 1 to 2 boiling chips. You're going to take your reaction mixture that's done with the reaction and has your product in it. Place it on top, no watch glass. And then you slide your flame right underneath it. Okay? So now you can see this is the hottest part of the flame. Okay, so now that you have the placement, you see that it's not at the hottest flame. What do we do now? And all we're going to do is we're going to just let it sit here and evaporate. To add water, if your beaker is getting low on water, take your DI water bottle and see your little spout. You can just squirt a little bit of water in the spout. And that will ensure that you don't go to dryness. Okay? And then you just let it continue to boil until your crucible is empty. And we'll go through and take periodic glances at what your crucible will look like as the water burns off. Okay, so not empty, but dry, or after getting just your product and no solution in your crucible. Okay, so let's go through and talk a little bit about preparing our sample for direct heating. So as you can see up here, our samples has some light pink spots that are dry, the darker pink so it has some water. So you're going to try to wait until almost all of it is completely light pink, and then we're going to put it directly on this gauze. So let's take a look to see how we do that. Okay, so once it has initially dried and we need to put it directly on our gauze, you're going to take this off, put it here, okay? And you want it, remember, on the metal gauze so you don't burn the lab bench. And now, with the beaker, with your tongs, you're going to invert it and take it around so it's underneath the lid. And then you just basically put it here. Okay, so you have to wait till this cools before you attempt to wash it. Now, the crucible can go back on directly on the gauze. Well, you can see there's still some water, the liquid that's being boiled off. So what we're trying to do is do some gentle heating and try to boil off the remainder of the liquid. Now, why is it bubbling? So remember, we had some light portions and we had some darker color. The darker color of the pink, you can hear it actually boiling. The darker color is from the water still being present. So what we're going to do is we're going to do gentle heating until all of it becomes a light pink as much as possible. And what you want to avoid is having this turn black, because that means it's overheating and reacting with oxygen in the air. So we'll talk about removing our sample from the desiccator, and then when we weight it, this is our first heating. So what you see here, this weight is after we finished taking it out of the desiccator, weighing it, and then we need to do our second heating. Okay, so once you have your sample cooled down to room temperature, you're going to take it out of the desiccator, and then we're going to go weigh it. Okay, so let's go through and I'll show you how we do the second heating. We're going to go ahead, get our sample set to dry again for our second heating. Let's go ahead and light up our Bunsen burner. Okay. Notice again, this is very low compared to the height. So what we're going to do is we're going to adjust our flame so it's a gentle heating. Okay. So here is going to be the hottest part of the flame, so here should be cooler. Okay. You can increase the gas if you need to, but we want to be very careful when it decomposes. What we'll do is we'll just heat it gently. Right now, all of our powder still looks nice and clean. There might be a little bit of darker, that could be shadow, but nice, light, clean pink. But you want to be careful because if you heat it too rapidly or too hot, you'll start turning it black. Okay, now that we're done with our second heating, we go ahead and see there's just a little small amount of a dark spot there. So it's good we took off our second heating, our sample from the second heating when we did, just because you can see there's a little bit of decomposition occurring. Basically, you go ahead, put this back in the desiccator, let it cool, get down to room temperature. So to be consistent between heatings, we probably let it cool in the desiccator around 15 minutes. Once it's cooled, we go ahead and weigh it again. And here you can see what the weight is for our second heating. And then we've finished, because if you can see this amount, the difference is within a milligram. So we're going to stop here. If it's a much lower weight, this weight increase, but if we had a much larger difference, then we'd have to do a third heating. But in this case, it was small. So once we do that, we're done with all our experiment, and now we have to do our waste disposal. So remember, you're going to look at the hood that has a label R120 on it. When we dispose of it, let me just show you what you do. We'll go ahead and unscrew our waste cap, or it will be off. Always check your labels. So in this case, hazardous waste. This is the general information. This is for chemistry R120 Experiment 3. So we want to make sure we get it in the correct waste. Okay. So once you've checked that, then all we have to do is just put our waste product in the bin. As you can see, we did a little bit of overheating, so it's turned brown because we're beginning to get a little bit of decomposition from too much heat. Just scrape it in. Now that we've done that, we don't need to wash here. All we're going to do is take this back to our sinks, wash it, and return it. Okay, so to recap, once we finish getting all our data, have a sign-off sheet signed off on our data and our procedure, you can complete your calculations at home. You're going to determine the mass percent of manganese in your sample and the mass percent of the chlorine, and then get your empirical formula. Besides completing all your calculations for this lab, you'll include a conclusion, which is about 3 to 5 complete sentences. First, think about the experiment itself. What would happen if the sample were cooled at your bench instead of the desiccator? What are the sources of error? Okay, because you've calculated your percent error. So what could be the sources? Why isn't it perfect? If you had a difference of, let's say, 5 milligrams between your first and second heatings, how would that affect your percent error? What would you expect? You can calculate it out and see what would happen. And if you had to optimize your experiment, what aspects of the experiment do you think that you could do, and explain why you can make those changes and that would improve your experiment. Complete your application of principles and then submit your experiment, upload it through Canvas, and that's experiment 3.